Hello and you are welcome to Success Science Tutorial, and this is physics class with Chuks. So today we shall be looking at this concept, half-life, and it is coming from a topic called radioactivity in physics. A lot of students are complaining about this concept that is so challenging and difficult. But actually it's not challenging, it's not difficult, so I'm going to simplify everything for you. Now let's begin. What then is half-life? So whenever you think of half-life, think of time. Take it for half of reductive material to decay. So half-life is the time taken for half of a reductive element to undergo disintegration. So since it is time, it is measured with the same unit of time. You can measure half-life in seconds, in minutes, in hours, in days, in weeks, in months, and so on. So it will represent half-life using T half. T half. Now let's take for instance that a certain reductive element has the initial amount 1000 grams. After one half-life, it will reduce to half of 1000, which is 500 grams. After another half-life, it will reduce to half of 500, which is what? 250 grams. After another half-life, it will reduce to half of 250, which is what? 125 grams. The thing continues that way. So you see that this is one half-life, this is another half-life, this is another half-life. Now, the number of half-life here is represented using small n. And the total time for this thing to disintegrate to this mass is represented using a small n, small t rather, small t. So there's a relationship in formula between number of half-life, total time, and half-life itself. And this is this formula. So the number of half-life is given to be equal to total time all over half-life. And this is going to be our what? Equation number 1. From this you can make T the subject of the formula to get to equation 2 by crossing and multiplying. If you cross and multiply, so T will be equal to like this. This will times this now, which is T equal to what? N times T half. You get what? N times T half. N times T half. So this will be equation number 2. Now, take for instance that a certain amount of reductive element has the initial amount N0. Then after a certain half-life, the thing undergoes disintegration. After a certain half-life, it reduces to N. So N is the amount remaining after certain disintegration, while NO is the initial amount. Then, how will I get the amount that has decayed? Then I'm going to subtract. So that amount decayed, I'm using D for amount decayed, will be equal to initial amount minus amount remaining. And this will be my equation 3. Then what of if I'm asked to get the fraction of the amount that remain? The fraction of the amount that remain will be the amount remaining all over initial amount equal to 1/2 power n, where small n is the number of what? Half-life. Number of what? Half-life. And this will be my equation number 4. Alright. Before we continue solving, let's also remember that there's one concept to add. We call it decay constant. Now, decay constant is the number of decay per second. So half-life in terms of decay constant is given as half-life is given as 0.693 all over decay constant. So decay constant is measured in, you measure it in per second. So this will be equation number 5. At this point, we shall begin at Jamb past questions. And we will know how to ask question, and from then I promise that you will be grounded when it comes to problem concerning half-life. Alright. So let's start with this question number 1. This is Jamb past question. And the question says the radioactive substance has a half-life of 8 days. So solution is this. Now, actually, the question is coming from the year 1998, question number 48. So it said that the radioactive substance has a half-life of 80 days. So half-life, which is T half, is 80 days. If the initial number of atoms in the sample is, so my NO is given to be 6.0 times 10 power 10. Now how many atoms would remain? So they ask you to find N. Then at the end of 320 days, total time is given. And that is what? 320 days. Now from all these formulas, please, the first thing I'm going to do is to get the number of half-life. So that should be the connection is, see the question here. So N equal to T over T half. So and that will be my half-life is what? Total time is what? 320. So right, 320 over half-life is what? Is 80. This cancel, this here, this is what? 4. So number of half-life is 4. Now remember we're looking for what? The atom remaining, that is the amount remaining. So now from this equation, which is the fraction of the amount remaining, you can get the amount remaining, right? So that amount remaining of initial amount is equal to 1 over 2 power n. I know this one, I know my small n, so I can substitute. You get? And that should be my n is what I'm looking for. All over. This one is given here, which is 6.0 times 10 power 10 equal to 1 over, this one is 2 power what? This is 2 power n. N is what? Is 4, right? Now, what will I do in this case now? I have to cross and multiply. This will times this, so I have 2 power 4, 2 power 4, and that 2 power 4 is what? 2 power 4 is 16. 2 power 4 is 16, so that should be 16 n equal to 6.0 times 10 power what? 10. Now I have to divide by 16. Divide by 16. My n will be equal to. Now, what can divide here? 2 can divide. 2 divided here is 3. 2 divided here is 8. Right? So we're having 3 times 10 power 10 power 10 all over what? 8. Let me use my calculator to divide this. So 3 divided by 8 will give me, so my n will be equal to 3 divided by 8 will give me 0.3 75, then times, this is my power please, which is what, 10 power what? 10. Now, I will shift my point from here because I'm not going to leave like this. So let me shift my point here. And if I shift my point here, I'm going to have what now? 3.75. Remember, the point I shift here will have 10 power minus 1, right? So that the power minus 1, that is minus 1 now, plus 10 will give you what? 9. So that should be what? 10 power what? 10 power 9. So the number of atoms that remain is equal to 3.75 times 10 power 9, and that should be question, and that should be option number what? Number 4. Now let's go to the second question. Okay, this is second question for us here, and this one is taken from the year 2007, question number 10. It says the radioactive substance has a half-life of 20 days. So, solution. Half-life is 20 days. What fraction of the original radioactive nuclei will remain? So you're asking to find out the fraction that will remain. It is not given. After 8 days. So total time is given. Total time is what? 8 days. Now, I think it's very simple. So let me get number of time. Number of half-life. So that should be number of half-life, and will be equal to total time of half-life. And that should be, total time is 80, half-life is 20, and that is what? That is 4. So now, the fraction of the original radioactive nuclei that will remain will be n over n naught, and that should be from the formula equation number 4, 1 over 2 power n. We are looking for this, right? And that is give us 1 over what? 2 power, and n is what? Is 4. And that is what? 1 over 2 power 4 is 16. So the required answer for this one is, the expected answer to this one is 1 over 16, and that should be option number A. Now let's go to the next question, please. So let's solve question 3. It says, this is taken from the year 2011. Question number 41. It says, the radioactive isotope has a decay constant of 10 power minus 5 per second. Calculate its half-life. Now these are the options. Now we have formula for decay constant in getting or in finding the half-life, and that should be half-life equal to 0.693 all over decay constant. But we are giving this, right? And last time I told that this is measured in per second. So this is a decay constant. Now you substitute it. We're looking for half-life here. That should be half-life will be equal to 0.693 divided by 10 power minus 5. And that can be, I'm going to put that one in standard form. That should be like this. 1. So I'm going to have a 6.93 times 10 power minus 1, right? Divided by 10 power minus 5. I'll apply the law of indices. So I'm going to have something like this. I'm going to have 6.93 times 10. I will take 10. There are 2 10 here, but I have a division sign. So I will take 1. Now I'll subtract the powers. So the first power is minus 1, minus 5, minus 5. So I have 6.93 times 10 minus 1. Minus times minus is plus with my 5. So 6.93 then times 10 power minus 1 plus 5 is 4. So my half-life will be 6.93 times 10 power 4. And that is option number what? Which option has it? Then seconds, please. Option number A has the correct answer. Now, let's get to the last question for this concept. So let's do the last question. The question is taken from the year 2012, question number 47. It says, a piece of radioactive material contains 1,000 atoms. If its half-life is 20 seconds, the time taken for 1, 2, 5 atoms to remain is dash. Okay, from the question, let's write out what is given. Now, it said 1,000 atoms, which is the initial amount. So my N O is 1,000. Half-life, which is T half, is what? Is 20 seconds. And the time taken for, so we're looking for the time, which is T, is not given. The amount to remain is given, which is what? Capital N equal to what? 1, 2, 5. So now we are looking for this particular one. It's okay. I think what we are going to get, for you to get this particular one, now you have to get your number of half-life, right? Get the number of half-life, and that can be gotten using this formula that the amount remaining all over initial amount is equal to 1 over 2 power n. Now first get this one n, and that should be, we are given this one, right? Yes, and this is what 1, 2, 5 all over. We are given this one, which is 1,000 equal to 1 over 2 power n. We're looking for this. Now let's see common factor to divide. 25 into 1 to 5 is 5. 25 into 1,000 is 40, right? Yes. 5 into 5, 1. 5 into 40 is 8. So what I have 1 over 8 equal to 1 over 2 power n. Now let me write 8 in index form. That should be 1 over 2 power 3 equal to 1 over 2 power n. So I continue, and that should be what next? And this is 1 over means power minus, right? 1 over means what? Power minus. So I'm going to write 2 power minus. Then I'll put my 3 here. Equal to, remember 1 over means what? Power minus. Power minus. So it should be what? Power minus what? N. According to the law of physics, what happened now? I have to cancel out 2. Then negative will cancel negative. So my n, number of half-life, will be equal to what? 3. What I asked to find, please, we are asked to find what? To that time. And I think I can use this formula that says the number of half-life is equal to that time all over half-life. I'm looking for this, please. So I will make this one the subject of the formula. That should be my small t equal to n times what? Half-life. And that should be small t equal to number of half-life is got into the 3 times half-life is given to me to be what? 20. This is 20, please. 20 seconds is 20. So I multiply 3 times 2 is 6. That is 60. So time taken, total time is what? 60 seconds. What is the correct option here? That is what? Option number C. Please, we are going to stop here. Please don't forget to like and share, and as well subscribe to this particular unique channel. And I will be doing my best to keep helping you and give the best you need. Thank you.